be on our best behavior. Today is our day for visitors again, so you are going to be on your best behavior. Come in quietly, have a seat. All right, let's give you undivided attention, please.
All right, so occasionally today, my name is Mr. Story, and this is Mrs. DeLuca.
Good afternoon. Well, good morning, everyone.
Good morning.
We're here to add to what Mrs. Richburg and Mrs. Hinton are already teaching you about chemical properties and chemical reactions. So we're going to do some cool stuff today to kind of add to your knowledge of that, okay? Occasionally when we have you working, you might hear this bell. It just means to come back together, okay? And then we're going to debrief or talk about what we learned, okay? So again, I'm Mr. Story, like a book. This is Mrs. DeLuca.
Mr. Luca. Can you say hi, Mr. Luca?
Hi, Mr. Luca.
Hi, Mr. Story.
Hi, Mr.
Okay. So to start off, you might wonder why we have these apples laid out. It's not lunchtime yet, but this looks pretty juicy. So we're going to use this apple, right, to do an experiment, okay? So I'm going to cut the apple. And then Mr. Luca, you'll show.
I wanted to have a look at the apple. Okay, have a look at the apple and tell me what you notice.
It's cut.
It's cut. Thank you. What else? Huh? There are seeds. Uh-huh. It's fresh. Very good. It's fresh. Now, what do you think is going to happen to this apple if we let it sit there
It's gonna
for a
rot.
while?
It's gonna rot.
It's going to what? It's going to rot.
It's going to
It's going to change. The color is going to change. Okay. Somebody else said something there? What color do you think it's going to change to? Brown, orange. Okay, I think you're very good at making predictions. You all know what's going to happen to this apple. Does anybody know why that's going to happen to the apple?
air. Yeah,
Because it
air.
has air? Wow, you're so smart. My gosh, this group is so smart. I'm loving it. Well, we're going to study more about that today, and that's why we cut the apple. We're going to be looking at the apple as we move along throughout the class.
All right, so we're going to lay these over here and check back and look at them later. And Mr. Luca's going to get a quick picture of those so that if they do happen to change, then we'll be able to explain why. Okay? All right. So, let's see. Okay. So we've observed the apple and we made some predictions. I heard someone say it was going to rot, right? I heard someone say what was going to affect it?
The air.
The air. So have you ever seen an apple change color before?
Yes.
Okay. How long does it take?
Couple minutes.
Okay, a couple minutes. A little longer, a little less. Do you try to eat it before it changes color?
Yeah.
Okay. So we're going to move on, and what we're going to do at this point is we're going to tell you the objectives that we have for you today. There's always something that we want you to learn, and today our focus is that we want you to be able to identify chemical properties and then demonstrate how they can be observed, and then also describe the process of chemical reactions in the world. So chemical properties, chemical reactions, that's your focus. Being able to describe how they happen, okay? That's what we want you to learn, but then we want you to learn it by doing this. In this case, by reading, discussing, and writing a little bit about real world reactions that you might see, okay? So chemical properties, chemical reactions, reading, writing, discussing. Think you can handle that? Okay, all right.
Okay, and next we're going to watch a video. And this is a very short video about chemical reactions. So what I want you to do while you watch the video, it's very short, is I want you to identify one example about a chemical reaction. Yes, when does a chemical reaction happen? Or just one example of a chemical change, okay, a chemical reaction. So look for that. When we finish the video, I'm going to be asking you to get that information to me, okay? Well, Mr. Story will. So pay attention.
So what are you supposed to be looking for in the video? Wait. Say it all together now. What are we supposed to be looking for? Chemical change,
Chemical reaction.
chemical reactions. How many are you supposed to find? At least?
One.
At least one. Okay. All right. You ready? Okay, here we go.
Chemical properties describe the ability of matter to react or combine with another matter to form a new substance, a new kind of matter. Although it's pretty hard to observe a chemical property. For example, pyrite and gold look a lot alike, but pyrite is made of iron and sulfur atoms. It has some of the physical properties of gold, but it's fool's gold. People sometimes use acid to tell gold and pyrite apart. The sulfur in pyrite reacts with the acid to produce a gas. Gold does not. Another chemical property is the ability to burn. This is called combustibility. Flame tests can be used to identify substances based on the color of the flame they produce when burned. Barium produces a green flame. Sodium produces a yellow flame. And potassium produces a violet flame.
So, what were some of the chemical reactions you saw? Ms. DeLuca is going to actually write those down for us as you tell her. So one at a time, raise your hand if you saw a chemical reaction. Remember, whatever you saw may be that. So yeah, know what you got.
When they poured that water on that little rose gold, I forgot what it's called.
Acid pyrite, very good.
Right.
Pyrite.
And what did they pour on it? You got acid on top of this fool's gold, right? Okay. We saw a reaction. What was the reaction that you saw?
Gas.
Right? Gas being released, yeah? What was another reaction that you saw? Anything else that was happening?
When they tested the firecrackers, like with potassium and other things like that,
Right. And how would you describe that? Like what different things were being shown?
like different elements,
Okay.
like substance like potassium and something else.
Right? And how did you know they were different elements?
Because they were different colors when they set them off.
Different colors, right? As soon as the fire hit that element, it made a different color. Pretty cool. Any others that you saw? Yeah.
Well, I don't know if it was coral when it was burning.
Right?
Yeah.
And so what do all those things have in common? Poured some acid on some pyrite, saw some bubbles, some gas come off of it. Set fire to some substance, saw colors popping off. What always has to be happening for you to see the chemical property? I just heard it. A reaction. Nice. What's your name, man? Nice, Arturo. Perfect. Reaction, right? Chemical reaction. So these reactions, you can only see them when something is happening to the substance, okay? Any others that you saw? Before we move on? All right, cool. Let's go ahead.
Okay, so we're going to be looking at some words that you need to learn today for your reading, okay? And the first word is reaction. I want you to look at the picture because we're going to be looking at these elements today, okay? So our element is going to be the shovel, and it's going to combine with what?
Water.
With water, and it's going to have a
Rust.
okay, rust. So we're going to whisper the word reaction 3 times.
Sorry. All right, I'm going to do it again since I missed it. Will y'all do it with me since I'm slow like that? Reaction, reaction, reaction. Are you whispering over me?
Okay, so we're going to put this word reaction into an example so we can understand it better. So when iron gets wet, the chemical reaction makes it rust. So what is our element here? What is happening in the picture?
The metal
What is this?
rusting.
The metal is rusting. Okay, good job.
Does that take long or is it a pretty quick process?
It takes long.
Okay. Would it be quicker for this to rust or for the apple to change?
Whatever change.
So some chemical reactions happen fast and some happen
Slow.
Good.
Okay, I forget we can just stop there, right? Okay, the dictionary defines reaction as responding to an action or force from the outside. So this shovel is reacting like this to a force from the outside. What's that force? What is the force? Is rust a force or is that rust a reaction?
Reaction.
Huh?
Right here, she's got it.
Don't be scared if you make a mistake. It's okay. We're all learning about reactions right now. What over here? Water is what? The force. Yes, water is force because does the water belong here? No, it comes from the outside. Okay, so when the water touches the iron, what happens to it?
It changes.
It changes, or a new word for it would be it reacts, right? Can you say reacts?
Reacts.
The iron reacts. It reacts to what? To what force?
Water.
The water. Very good. So the iron reacts to the water, causing what? Causing it to rust. Yes. Thank you. Now, a student definition for reaction is a change in behavior after something happens. So what changes in our example? What changes?
The iron.
The iron. Do you know what this is? This is a shovel. Can you say shovel?
Shovel.
Have you seen a shovel before?
Yes.
Have you used a shovel before?
Yes.
Where do you use a shovel?
Backyard.
The backyard, okay, in a farm, okay. So probably you also saw a rust shovel, right? Have you ever seen one?
Yes.
Yes, okay. Thank you. Okay, so what we're going to do now is you're going to take turns with the partner saying and finishing this sentence. Blank had a reaction when blank, but we're going to model for you first, okay? We're going to do it with Mr. Story. So, for example, I'm partner 1 and he's partner 2. You're also going to have a partner in your group, partner 1 and partner 2. So I say, the iron had a reaction when it got wet.
And I would say, I had a sad reaction when my dog died.
Okay, so reaction, you can use the word reaction in many examples. So you're going to have 1 minute to do that with your partner, okay? So the person with the shortest hair starts first. So look to your right or to your left and pick a partner, and the person with the shortest hair starts first, okay? For 1 minute, you can say whatever you want using this blank. Blank had a reaction when blank.
Do you agree? Just take turns. Is this interesting? I'll go first, okay? So if you'll say, blank had a reaction when blank. Like, you can say, I have a reaction when blank, or whatever you want to say. But you say it. Listen, you have to go first and short. So I had a reaction when, you can say whatever you want. Someone pushed me in the You know what I'm saying? Use the word reaction. I had a reaction when he said,
Okay, good, yes. What are you doing?
we didn't listen to my reactions going on.
kind of reaction?
Happy? Hopefully not bad.
I'm happy.
Your reaction was nervous? You know, nervous. Reaction? So, I know.
What's one that y'all said?
Yes, I was nervous.
Oh, okay, cool. Parents have a reaction.
But I mean, he tells you.
All right. So let's come back together. Heard some really cool ones.
This is one, yeah, thank you.
Okay. All right. So
Oh, we have, okay. So now we're going to, with a partner, we're going to plan and act out an action and a reaction. So we can also react with our bodies, right? When something happens to us, right? I don't know, things can happen to you, right? Oh! Yes? So what happened? We reacted. What was the action? Who was doing? Okay, that was my reaction, right? I was scared, but why was I scared? What was the action?
Just me step forward and loud sound.
Yeah, Mr. Story stepped forward. Well, he kind of almost kills me, right?
but I didn't touch her. I just stepped forward, right, loudly, and then so her reaction was what?
She got scared, she stepped backward.
Okay, very good. So what we wanted to do now is to say, well, not the same thing, but we wanted to come up with one idea and act it out. Okay, you're just going to act it out there in your group with a partner. So think of something that can happen and you react to it. Okay? No touching, no physical. Okay?
Right. I didn't get her in a headlock or anything. All I did was jump, right?
Okay. Okay, you have 1 minute. Come on.
So you're doing something already. As long as they're not hitting, we're good. Right? Reaction. Scared me right now. So what was my reaction? Right? Try to think of different ones. What are some other action and reaction?
More like this.
Right? And then what did you do? Did you move back? Now see, no touching.
Okay, so can we have somebody coming to the front?
Alright, so we want some volunteers maybe, someone who's willing to get up with a partner and show the action and reaction. No contact, just showing it.
Yeah, let's use Jaleel, since he's already standing. Go ahead, Jaleel. He loves to perform in the class, everybody. Come on,
Really?
Jaleel. You and Steven. Look, Steven's up there.
Steven's
Go
up.
Cool.
ahead. Good job. Come on, everybody clap for Jaleel. I know he's an actor.
Okay, so what was the action?
Yeah, he's going out.
The actor.
Right, and then the reaction. Okay.
Okay. Ah, you're very good. Very smart, creative students you have.
Alright. So our next word is chemical property. And this word's a little more difficult, but it does have to do with the picture we saw before. The shovel, right, has an element in it called iron, which you probably learned about on the periodic table. It's in the metal family. Does that sound familiar? Okay. So the shovel has iron in it, and we already found out that the iron has a chemical property. But it can only be seen when you put water on the iron. So when you put water on iron, the chemical property, whoop, my bad, that we see is what? What's that chemical property? Rust, right? Okay. So now we're going to go ahead and do chemical property. I want you to say it loudly. All right, so I'm going to say it 3 times. I want you to say it with me, real loud. You ready? You with me? Chemical property.
Chemical property.
Chemical property. One more time.
Chemical property.
That was really lame. We're going to do it again. Okay? So chemical property. When I say 3, right, I want you to say chemical property 3 times. 1, 2, 3.
Chemical property.
Chemical property.
Chemical property.
Make sure everyone is saying it. All right. Here's a sentence that chemical property shows up in. Chemical properties cannot be seen by touching or viewing a sample. Remember, something has to happen first. And then when that happens, we get a reaction. And we see the chemical property. All right, so the dictionary tells us that chemical property means it's a characteristic of a substance that's only observed during a reaction. Okay? Some terms that are easier for us would be a part of a chemical that can only be seen when it combines with others. So you can think of these chemical properties as being hidden. They're really not easy to see. But when something else happens to that substance, then we can see that chemical property, like rust. Okay? All right. Now listen closely. Now I see some of you are messing around over there. What you looking at, man? What's in that notebook? I just had a reaction to him not paying attention. Reaction. All right. So if you come back with me, right, we want you to clap your hands if the sentence you see describes a chemical property seen when chemicals react. Now that sounds like it might be difficult, but it's actually very simple. You're going to see a sentence and a picture, and the 2 things in the picture, when they come together, if one of them changes permanently, then you're going to clap. But when those 2 things come together, if they don't really change, they stay the same, they're just sitting there together, then you'll do nothing. All right? So let's try one. If these 2 things that come together change, if one of them is changed permanently, you clap your hands. Okay? Let's see what we got. A diamond sparkles when light shines upon it. Is the diamond or the light changing permanently when they get together?
No.
That's awesome, man. No one clapped. You are on fire. I love it. All right, try another one. You ready? Remember, if there's a change, a permanent change between one of them, you will clap, okay? All right. Cake mix changes from liquid to solid when it heats up. Perfect. Well, I knew it was going to be lunchtime, and Mrs. Richburg let us know that. And said y'all might like to eat cake. So. Okay. The mouse squeaks when it sees a cat. Got a high-flying group here. Right? Because the mouse, after the cat goes away, is the mouse changed forever?
No.
Still a mouse. All right. The phone rings when I call your house.
No.
Right? Because the phone ringing doesn't make anything permanently change. Right?
Make a sound.
Right. After a while it stops ringing. There it is again. Nothing's changed.
Well, what does that mean?
Yeah, I don't know. It's ringing pretty hard, right? But I know this, that if the phone rang so hard that it shook and jumped, it would later be sitting still right after it was done. So good question, though. Okay, iron rusts when it gets wet. All right. Good to go. Is it? Okay, we're going to pause there at step 6, and Ms. Richburg's going to give you some directions for lunch.
You gonna be here today?
Yes, we'll see you when you get back.
Alright, let's line up quietly. We don't want silent lunch today, so.